Okay, so the instructions say
this is
classify,
test but we are going
that's
to
like
learn
when you go into a produce store, you say,
we're
oh,
going to find
the fruit over here,
the
they're bananas.
circumference of the circle.
fruit over here,
Circumference,
these are oranges.
You go
you got
all
apples.
the way around.
Maybe in the apples there's different types.
The circle, if you had a tape measure,
kind of naming
you
the
started
types.
right here and you walked
This
all
says
the way
classify
around. This is the
each
formula. There's
triangle
two different formulas.
by its angles and
if
by
you know
its
the
sides.
radius,
So
circumference is
for triangles,
2
there
pi.
are 3 types
2
of
pi
angles.
means the same
There
as
are angles,
360 degrees.
so I'm
that's
going to draw
how,
an angle.
That's how many degrees you
Angle,
walk around the circle.
those look very
Well,
similar.
in radians,
So I'm going
those
to put
two
angle.
mean the same thing. One just has a different label.
That is less than
Kind of like
90 degrees. So
4
one of the things I
quarts
tell kids, it's
is
little,
the same
it's
as
acute.
1 gallon.
Little
They're
angles
the same
are
amount.
cute.
They're just
So
labeled differently.
these are acute angles.
So
And that's
2
kind of a
pi
silly,
times
way, but
radius.
it might help you remember.
So in
And
this
then
case, we would just
an
say
angle
2 pi.
is
Sometimes
exactly
people on 90 degrees
will
that's
want you to use
just
this.
right. 2 pi is roughly 3.14. So there will be
right
some
angles,
teachers that want you to
are
just get an approximation.
the sides are
If
perpendicular
that's
to
the
each other,
case, you use
so they form an L, and we indicate that by putting this little square
I want
down
you to
here.
use pi.
Okay,
To get used to using pi.
and
now
that angle
the radius
is 90 degrees. And
is
then
two,
in
you
a
have to put the
triangle,
label
there's a
in there, 2
possibility
kilometers.
of having
So now
a large
the pi is part of it, but what you do is you
obtuse.
multiply the rational numbers.
So
2 and
because
2,
you
that's
can
pretty
have,
rational.
and that's
2 times
larger
2 is
than
4
90 degrees.
times the
So
pi.
if you have,
and then
if
the label,
all 3
that
angles
didn't need to be look like a
are acute,
multiplication,
then you
the
have an
label
acute
is
triangle. If
kilometers. Now, if you
angle
wanted
is
to
90,
know
then you have a
about
right
how much that was, you would
triangle.
just you could
And if one angle
4 times 3.14, so
is
that would
larger
be
than 90,
about
then you have
12.56
an obtuse triangle. Okay,
kilometers.
those
Roughly.
are by the angles. Because
Now
pi
let's
goes on
shift
forever, the
and
decimal
focus
value.
on our sides.
So all we can
So
get,
there's 3
when we
possibilities. Turn this into
If
3.14.
all 3 sides
and multiply that by 4
are the same,
we
and
can
you
only get an
indicate that
approximation
by
so we
1
use
tick
the
mark. By the way, that
approximation.
means all
Simple.
of the angles are the
Now,
same. This is what you have to be
This is
careful
called
about. Here
equal
is the second formula.
and all 3 sides are the same.
If you know the diameter,
Equilateral
well, the diameter,
triangle.
so if we go all the way across
Okay.
again,
That's another
then
radius.
2 sides are the same.
Well, 2 kilometers and 2 kilometers is 4, so the diameter is twice the radius.
That means the opposite
So
angles
if
are
the
the same.
diameter is
That
twice,
is an
then the
isosceles.
radius, and some students
is
in
half
my
of the
class, they
diameter.
said, so in this case,
something
we would
pretty cool, and I wish I would
pick
have
out
known
a radius,
student.
or
It
we
was
could
the
just
day that I
say,
wasn't there.
let's use the diameter.
But one of the things that
And in
they
that
said
case,
is
the
that
formula is
that third
diameter
angle
times pi.
So for this
is
one,
not the
we'd
same.
say
So it's
2
isolated. So
I mean,
the first part of
10.2 feet
isosceles. So that's how they're
times
remembering
pi.
it. So 2 sides are the
You'd
same.
have to rewrite it because we want
2
feet
sides same.
as the outside label. So that would
Equilateral,
be
3 sides
10.2
times pi feet. And then you've got
Okay.
a possibility.
Now we're going to go to area problems where none of the sides.
The first one's easy.
So now we're looking for no
Whoops.
sides are the same. And when that's the case, all of this inside measure, let me move this
If I
down.
could if I wanted to take the time to color that all the way in, we're not taking a tape measure
this
and walking
This
all
would be
the way around outside.
a scalene.
And how you show
filling
that
in
how much do you
is,
have to fill in?
the
So
smallest
the area
angle
for a
opposite
circle
side
is
would get 1 tick
pi
mark. The
times
medium
the
angle
radius.
opposite side would get 2 tick marks. The
And
largest
you have to
angle,
put the units in there.
3 tick marks.
So UN for
And
unit.
notice the tick marks
squared.
represent.
So
So,
in this
over here,
example,
when 2 angles
pi
2
times the
sides are
radius
the same,
is 4 meters.
they each have 1
We're
tick
squaring
mark.
both.
Over here, all 3 sides
and
are the
then
same.
we're going
1
to
tick mark.
put
So if there are
pi
3
to the
sides,
right of
there have to
the
be
rational
3 different
number,
types of tick marks.
and then meter squared
so
will
this
be
is
the label.
called a
And
scalene.
then 4
And
squared
again,
is 16.
how students
So that's how you would
mentioned
write
it.
that answer. scales,
then again, if you had a teacher that they wanted you to round, this certain animals, they're all different.
That's 3 point.
So that's how they remember it.
Roughly 3.14.
Just multiply that by 16.
All three sides,
and you're going to
side
get
same, or a better way to say
49
that, maybe
something, I
3
think. Or maybe 50
different
point something
sides.
meters.
It also means
squared.
3 different angles.
Okay. Now what happens when you find
this also means
diameter?
Well, same angles.
The area is pi times radius.
This means 3
squared, and remember to put the
angles
units in
are
there.
The same.
So you're going to have to take the time.
So knowing that,
what the radius is, because this is
you're
the
just
diameter.
going to have to kind of
Half
eyeball
of this.
That's
Right?
definitely less
Visually,
than 90.
you can see
That's,
one side is shaded, not the whole
90
side.
looks like
So half of
like
16 is 8.
So if you tilt
half
this
of
one
2 is
sideways,
1, so that's 8.1 inches.
those are all
so where the R is
less than 90. So those are all
in the parentheses
acute
8.1 squared
angles.
So we know for sure,
Unless you like
this
multiplying
would be
fractions,
I would, in parentheses, 8.1
an acute triangle
squared.
But then you also have to
65.61.
look at,
So I'm going to say
one arc,
roughly,
so across from here,
65.6.
2 arcs, that means those 2 angles are the same.
Oh, guess what
2
I didn't
tick
put
marks
inside here? I needed
3
to put
arcs,
the inches in there.
3 tick
Because
marks.
the inches,
And now look at
all
also
3 sides are
squared.
different. So this
So
is 65.6, an acute scaling
inches.
triangle. 65.6 pi inches
Ah,
squared.
right away.
And then notice, because I'm
We
rounding,
noticed that's
I put
right.
the approximation symbol. And this one is less than 90, and that one's
Okay.
And so what you have to pay attention to, oh, I'm going to come down here and do some other area ones.
All
is
right.
that those aren't the same, so it can't be isosceles. So we would say that this is a right area.
Well,
because
one
in a
formula
triangle
for the
there
can't
have
have a triangle.
There
Two,
are others.
So
But
I would
usually
give
when you're
this
first starting off
3
doing area
arches.
problems, the area for a triangle,
1 tick mark is
2
1
tick
half
marks, 3 tick
times
marks.
the base.
This would be a
times the
right
height.
scale. You have to
Scaling
identify. The base is the one that's perpendicular to the height. And notice they have the height in red, and perpendicular to the height is the base.
Another right,
So we can
plug
go
in
ahead
those numbers
and put right 1/2 times 3 kilometers
and
times the height 1.9 kilometers.
Both of those are 1 arc. That means,
and because it's an area, kilometers times kilometers, you're going to end up with kilometers squared. So that would be a right isosceles.
Now, if you're going to do this with your calculator, you can convert
1/2 to 0.5.
This is a very large
3
angle.
Times
that
1
definitely obtuse.
And you get 2.85.
Very much bigger than 90 degrees.
So that is an obtuse triangle.
They wanted it rounded.
And then
you
notice
say
about
it still has 2 sides
the
the same,
kilometers
or 2
squared.
angles the same, which means
So that's
the side opposite the 2 angles,
just kind of
those
that
2 sides are
generic
the same.
triangle. So that is also
Now we're going to have a
isosceles.
rectangle.
So that's obtuse isosceles.
Now a rectangle where the sides are not the same, that we call it rectangle. When all 4 sides of a rectangle are the same, we call it a square.
Ooh,
it's still a rectangle.
This angle right
but
here
it's a specific
is
type
the largest
of rectangle.
And look at
Right
also
about
rhombus.
there would make that 90
So
degrees.
it is a square.
So that's
the
an
area
obtuse.
for the area formula for a rectangle is length times width.
Because one of the
I would
angles
always label
is
the
bigger than
longest
90.
side as length, the shortest side as width, and put it in the formula.
And all
as
3
it's
sides
described.
are different.
So the
obtuse,
length is 3 centimeters
scaling.
times the width, which is 2 centimeters. Well, that one's easy.
And then
6.
it doesn't have the markings.
Squared is the area.
All the angles. So
Now,
you could
let's
say
pretend for a
acute
moment.
scaling.
But I think what they want us to
That you
recognize,
didn't have
those sides
this.
all look the
And
same.
what we
had, so
was
this
a square,
would be,
and each
and
side,
by the way, all
each
equilateral triangles equaled 3 centimeters. Well, the area formula
must
for
be acute.
a square
A
is
triangle
has 180 degrees,
and
if
their
all 3
units
angles
squared.
are the same.
So in this case,
Are the
we
same.
would say
Divide that by 3.
all inches
3 angles
squared, and that would
60
be
degrees,
which 9 inches squared.
All 3 angles
now,
are
that's
less
not
than
what
90.
we have,
So,
but that's just an example of how you would do a square,
equilateral
triangle.
Okay, now we've got a parallelogram.
So this is how you classify
kind of
triangles by their
a bent
angles
rectangle,
and their sides.
kind of.
So we have this height in red, and then the side perpendicular, you know it's perpendicular because of that right angle. This would be the base. And the area for a parallelogram is base times height. So the base is 2.5 inches times the height of 1.7 inches. I think that's 425, but 4.25. So 2.5 times 1.7. Yeah, that gives us 4.25 inches times inches is inches squared. So that's the area of a parallelogram. Sorry, I almost started to spell that incorrectly. Parallelogram. All right, now we've got a trapezoid. You have some flexibility with how you label. The red perpendicular line is height. And notice, this is perpendicular to 2 lines in a trapezoid. You've got one set of parallel lines, and that one's obvious because this line and this line are definitely not parallel. They're going to end up, if they keep going, they're going to cross each other. So the yellow lines are parallel, and I usually call the top one base, not base I, base 1, and the bottom one base 2. You could do it reverse. You could call this the top one base 2, the bottom base 1. That part doesn't matter. So the area of a trapezoid is 1/2 times the height, and then that's going to be times the 2 bases added together. So let's go ahead and try it. It's 1/2. The height is 1 meter. Well, 1/2 of 1 is 1/2. 1/2 meters. We're going to add these 2 bases together. So 0.9, because that's base 1, plus meters and 1.9 meters. Add those 2 together, and we have 2.8 meters. And 1/2 of 2.8 is 1.4, but meters times meters is meters squared. So this inside area, the area is 1.4 meters squared. All right, there's other shapes, and triangles have other formulas, but this just kind of gets you started with basic area formulas.